In this video, we'll be reviewing for the Chapter 4 test on quadratic functions and equations. So we're going to begin the first video with what we learned in topics 4.5 and 4.6, which were completing the square and the discriminant and the quadratic formula. So here we're going to go over a problem completing the square. I'm going to be checking when I test you that you can do individual steps that are unique to this method. So here we have a problem, x squared minus 10x minus 49 equals 26. We're solving the problem using the completing the square method. It says, what would you add to both sides of the equation to complete the square? So when you complete the square, your goal is to get the ax squared plus bx by itself. They already did that in this problem. So the next step is to take your b, in this case it would be the negative 10, and you divide it by 2. So here negative 10 divided by 2 equals negative 5. And then to complete the square, what you do is you add negative 5 squared to both sides. So when you do that, that's completing the square. So here in this blank, I would put a negative 5 squared. In this blank, I would put a negative 5 squared. And that would be the answer to complete the square. Here we're continuing with the same problem. So we already completed the square, and now it wants to know how would we rewrite the left side of the equation as the square of a binomial. Here they're telling us that they want to write it as the square of a binomial. Remember, binomial means two terms. So here I'm going to change it. Instead of x squared minus 10x plus negative 5 squared, we're writing it as the square of a binomial. So I'm going to set it up, and it's kind of like factoring, so I put x here. And then in parentheses here, I have a minus 5. So that's what I put in my parentheses here when I rewrite it as the square of a binomial. So that would be what goes on the left-hand side there. On this next problem, we're continuing with the same one. Now we're on the last step. So now it says finish solving the problem. What would be the two solutions? So here it's checking that you know how to solve. So now that we rewrote it as the square of a binomial, to solve it, what you would do is you would take the square root of both sides. So here, when you do a square root of a square, it cancels. So it's like I'm left with x minus 5. And then the square root of 100 is 10, but we need to put that positive or negative sign in front of it because we can have up to two solutions. 10 squared is 100, negative 10 squared, or negative 10 times negative 10 is also 100. Now I'm going to separate this into two problems. I have x minus 5 equals positive 10, or x minus 5 equals negative 10. And I'm going to solve both of these to get my solutions for x. So for this one, I would do plus 5 to both sides. That comes out to 15. I would also do plus 5 here, and that comes out to a negative 5. So my solutions for this problem are negative 5 and 15. This next problem is a different completing the square problem. They already did most of the steps. Here it says, what would you get on the right side of the equation for square root of negative 49? So basically they're asking us to take the square root of negative 49, because here when we're solving we would square root both sides. And they want to know what the square root of negative 49 would be. Well, because it has a negative, this means it's going to be imaginary, because you cannot take the square roots of negatives. So remember, since you cannot square root negatives, instead of being real, you get an answer that's imaginary. Since it's imaginary, you have to put that little I in your answer. So square root of 49 would be 7. So square root of negative 49 would be 7i. And then don't forget, you have to put that positive or negative sign in front because there can be up to 2 answers. This next question is moving on to a new topic, the discriminant. So what is the discriminant and how many solutions would this quadratic have? So your discriminant, the formula is b squared minus 4ac. And then if you have a positive discriminant, that means that your graph would have 2 real solutions. If you have a 0 discriminant, then your graph has 1 real solution. Notice your solutions are your x-intercepts. And then if you have a negative discriminant, your graph is going to have no solutions. In other words, it does have some, but the reason you're not going to see any real solutions is because they're imaginary. So this one would have no real solutions, but it would have 2 imaginary solutions. So let's go ahead and find the discriminant, and then we'll say how many solutions this one has. So I'm going to label my A, B, and C. So here my A is -8, my B is 6, my C is -4, and I'm going to plug those into my equation here. I'm going to start working this out. 6 squared is 6 times 6, which is equal to 36. Then 4 times -8 is -32. -32 times -4 is positive 128. And if you do 36 minus 128, you get -92. So my discriminant is equal to -92. Since my discriminant is negative, that means that I'm going to have 2 imaginary solutions. In this next problem, it says for this function, is the discriminant positive, negative, or 0? So let's go ahead and look at this graph. This graph has 2 real solutions. Remember, we learned if there's 2 real solutions, it's because our discriminant is positive. And remember, your solutions are your x-intercepts. Here it says, if the discriminant is equal to 0, how many solutions are there? Well, we learned that a 0 discriminant is going to have, on the graph, 1 real solution. This last question is actually reviewing the quadratic formula. You'll notice your discriminant is part of the quadratic formula. So here we're going to solve 2x squared minus 9x minus 35 equals 0 using the quadratic formula. So I'm going to start by labeling my A, B, and C. Here my A is 2, my B is -9, my C is -35. And I'm going to plug those into my formula. So I have x equals, I have to draw that negative, then I'll plug in b. Everywhere I plug in for a letter, I'm going to put parentheses, and I'm going to put my numbers in there. So for b squared, I'm going to put a -9 in parentheses. For a and c, I'm going to put 2 and -35. On my denominator, I have an a, so there I put my 2. And now I'm going to start simplifying this or making it smaller. Here, I have 2 negatives. Anytime you have 2 negatives, it becomes positive. I'm going to leave my square root empty for now. On the denominator, 2 times 2 is 4. And I'm actually going to work out my discriminant, the part under the square root, separately. So I have -9 squared minus 4 times 2 times -35. Negative 9 squared means you're doing negative 9 times negative 9. That's positive 81. 4 times 2 is 8. So I have 81 minus 8 times negative 35 is going to be 280. Now, it's negative 35, so sorry, it's minus. And then 88 times negative 35 is negative 280. Here, since there's two negatives, it's going to become plus, and that actually comes out to 361. Now, this that we just did is our discriminant. Since it's positive, we already know it's going to have two real solutions. So I'm going to insert the 361 into my square root. And now you could write your answers like that. 9 plus square root of 361 over 4. Or 9 minus square root of 361 over 4. So x could equal either of those answers. You could take it a step further and actually simplify it. This only works though if you get whole numbers. So if you do square root of 361 on a calculator, the square root of 361 comes out to 19. So if you wanted to actually make it smaller, this would become 9 plus 19 over 4 and 9 minus 19 over 4. Here 28 over 4 is 7. Here you get negative 10 over 4, which if you divide by 2 simplifies to negative 5 halves. So another way to write this answer would be 7 and negative 5 halves. So if it does get a whole number when you square root it, you can simplify it further. If you don't get a whole number when you square root it, you can just leave the square roots.